Okay. So, well, last time we introduced the dimensional analysis chapter, and we mentioned that it's very important to non-dimensionalize equations because we can come up with generalized forms. Okay, and we went over some very important dimensionless numbers as Reynolds, Mach number, etc. One of the important numbers were the drag coefficients and lift coefficients. And if you remember, we said that they have uh, important applications in case of aerodynamics and hydrodynamics. And in this case, for example, how we can do a general analysis. First, we start to determine what are the important characteristics determining the flow behavior. So, for example, let us say we want to study the aerodynamics of a car, of an airplane, etc. The important properties will be the upstream velocity and pressure, the characteristic length of the body, and the corresponding forces exerted on the body, the lift forces and drag forces. Okay, lift and drag forces are due to what? Are due to, if you want, the net force acting on the system, and is due to combination of shear and normal forces. Okay, so after you do integral of forces over the system, you can divide the force components into two parts. The lift force is the net aerodynamic force perpendicular to the direction of motion of the object, while the drag force is the net aerodynamic force parallel to the direction of motion of the object. And as we said, the net values of lift and drag will result from the local pressure distribution and the shear stress distribution on the body surface, because these forces are determined by integrating these pressure and shear over the area. Okay, so how we can come up with an analysis and use it in general cases for such cases. What we will do, for example, is the following. We'll define important dimensionless parameters that seems to be interesting. So first, we are interested in the lift force, but the lift force has a certain unit. So we can define a certain coefficient that is dimensionless that is related to the lift force. This is called the lift coefficient. Okay? So we should divide the force, the lift force, by a number having the same unit of force, and at the same time is function of important parameters of our problem. So for example, here, we already mentioned that the upstream velocity is an important parameter, the characteristic length L, and of course, we might have several characteristic lengths that are important, not only one. In case you have a sphere, for example, then D is enough. In case you have a cylinder, then you will need the diameter, and the length F. Okay? So now, for example, here, in addition, one important parameter is the type of flow. And for the type of flow, the characteristics are rho and mu. Okay? So depending on the type of flow, if it's water, if it's air, rho and mu will vary. So if we look at a combination of parameters having the same dimension of F, we found out that by doing rho times u squared times a, we get the same unit of F. You will tell me how I will know this. We'll develop together methods that will allow us to determine the dimensionless groups. Okay? With practice, you will directly know. So now you know directly that F has the same unit of rho u squared a. So you will know that they will form a group. But in general, if you have any variables, we'll learn techniques to give us what are the dimensionless group of the problem. So as we did for lift, since drag force is also an important parameter, we'll define another dimensionless number, which is the drag coefficient. So based on the same procedure, it will give us Fd over half rho u squared a. We can also define the skin friction coefficient related to shear, and as you can see, for example, you can directly reduce what will be its dimensionless number, because the only difference between f and tau is that tau is f over a. So if you eliminate a from here, you will get your dimensionless number of skin friction coefficient, which is tau over half rho u squared. And finally, an important coefficient also is the pressure coefficient. This coefficient is important when you want to study the materials used for your car, for your airplane. You should know what is the maximum pressure acting on your system. So you need to define a pressure coefficient related to pressure on your system. So this can be done by doing P minus P infinity. And the unit of P minus P infinity is same as shear. This is why the denominator will be common here. So to get a dimensionless group, you should divide by half rho u square. Now, why half? You can tell me why half. I can just put rho u square a. It's true, okay? But the idea of half comes from Bernoulli relation. In Bernoulli relation, you have the dynamic pressure is rho v square over 2. So this coefficient, you can eliminate it or you can keep it. It will not affect, if you want, your general results at the end, okay? Because if you define it without a coefficient or with it at the end, the general results when applied will lead to the same final answer. Okay, so now let us proceed. For example, look how we can do experiments. We can say we need to determine how the drag coefficient is varying with Reynolds number. Okay, so for whenever you have a flow, in general, in majority of cases, Reynolds number will be one of the important dimensionless parameters. So here, let's say we want to see how the drag coefficient is varying with Reynolds. So all we have to do then is to do experiments, vary the Reynolds number, and measure the drag coefficient, and plot a graph. Now, for your graph, you always have, you know that, for example, in this case, let's say you have flow over a cylinder. Let us say that dimensionless groups are the following. The first one is the drag coefficient CD. The second one is the lift coefficient CL. Also, I have Reynolds number, which is important. I have L over D, because here the cylinder has two characteristic lengths, L and D. So if L over D vary, the graph will be different, okay? And let's say you have a rough cylinder, it's not smooth. So also another parameter to account for roughness is epsilon over D. So what can you do here if you want to represent the effect of all of these parameters? So first, let us start with CD. CD is function of what, let's say? CD can vary with Reynolds, can vary with L over D, and can vary with epsilon over D. So what you can do is, you can fix, for example, in this graph, you say, I will fix epsilon over D, for example, and just vary L over D, and draw several graphs for different values of L over D, and then I will come up with, for each L over D value, I will get a graph, and then I can read for a certain Reynolds number what will be the drag coefficient. Okay. Now, if in case I want to see the effect of epsilon over D, I need another chart representing several values of epsilon over D. So, for example, here, if you want to study the effect of roughness, you can fix L over D then and vary epsilon over D. And you can do a series of graphs to have all conditions implemented in your graph. Okay. Now, we can do this in several applications. So each application will have its own charts. Okay. For example, another important application when you want to design airplanes is to study flow over a wing section or airfoil, because the wing has the same shape of an airfoil. And an airfoil is characterized by its chord length, which is the distance from the tip here to this point, okay? And you have also an important parameter is the angle of attack. What is the angle of attack? The angle of attack corresponds to the angle between the axis of the airfoil, okay, and the horizontal direction. So here, you can define for different angle of attacks what will be the relation between, let's say, how the drag coefficient and lift coefficient will vary with Reynolds number. Okay, so for example, here in this graph, they illustrate the variation of lift with alpha. So here, then, if you want to find the relation between lift coefficient and alpha, you should fix all parameters and just vary alpha. Okay, so I fix, let's say, the characteristics of the airfoil. I fix the upstream velocity. So I am working for the same Reynolds number, and I vary then the angle of attack, and I measure then the corresponding lift coefficient. I can come up with a graph giving how the lift coefficient is varying with alpha. Okay, and this will help me into the design of my airplane, because it will allow me to select the optimum value of alpha to optimize lift, because lift will help my airplane in moving. Okay, now, so this was just an introduction to tell you the importance of dimensionless parameters and how we can use them in real life applications. Now the next step will be how to determine what in a certain problem, what are the dimensionless numbers of interest, and then to proceed to experiments. And for example, in the example of the cylinder, we said that the main parameters, let's say, were CD, the main dimensionless number were CD, CL, L over D, epsilon over D, and Reynolds. And then we should do experiments to construct graphs. To be able to know how these experiments should be performed, we should do the following analysis together. And after we do this, you will understand how this will help us into constructing charts. Okay? Before going through the theoretical steps, I will start with you an example, because through the example, we'll understand exactly all steps, and then you will go back to the steps so that we summarize the method. Okay? So I will start with a simple example here. For example, let us consider a force F applied on a particular body that is immersed in a stream of fluid, and that depends only on the body length L, the stream velocity V, the fluid density ρ, and the fluid viscosity mu. In this problem, they gave us all parameters of interest. In general, if they don't give us parameters of interest, whenever you have a moving flow, then of course V will be a parameter, ρ and mu will be parameters. So this is in general, in all cases where you have a fluid, this will figure out in the parameters. For example, now, if we are interested, let's say, into getting the force over a system, okay, and the system is characterized by a certain length L, then the additional parameters to consider will be F and F. So here, first we define the number of variables, which is symbolized by N. N represents the number of variables, and in this case, it's equal to 1, 2, 3, 4, and 5. So we have 5 variables in this problem. So first we determined the number of variables that we have. The second step will be to find the dimensions of each variable. You can put the dimensions or in MLT system or in FLT, any system you want. You can work in the system that you want, okay? Let us say here we want to define these variables dimensions in MLT system. I start first by the force. If you forgot, no need to memorize anything. You can derive back all dimensions. Force is mass times acceleration. And mass dimension is kilogram, so it's big M as dimension. And acceleration is meter per second square, so it's as dimension is LT minus 2. So for F, the corresponding dimension is MLT minus 2. Now for L, it's a length, so it's very simple, it's L. For velocity, it's meter per second, so it's LT minus 1. For density ρ, it's kilogram per meter cube, so it's ML minus 3. Now for mu, if you remember last time in class, we said if you forgot mu, okay, all you have to do is to go back to the relation tau equals the mu times del u by del y, and you can find again what is the dimension of mu, okay? And the dimension of mu, as we derived last time, is m l minus 1 t minus 2, because we found out that it was in kilogram per meter per second, okay? Now, once you do this step, okay, the next step will be to determine what is called the number of dimensions involved. So n is the number of variables, j is the number of dimensions, okay? How many dimensions are involved here? M, L, T, okay? So 1, 2, 3, because you have, and if you go over all variables, you don't have anything new, L, T, M. So M, L, T are the variables involved. Number of variables involved is 3. J equals to 3. Now, once you determine the number of variables and the number of dimensions involved in these variables, you can say that we can set, okay, that J is at least maximum equal to 3. You will understand more when we do examples. J can be, the number J can be smaller or equal to 3. How we know? What do we mean by this? Here we have 3 variables. We have 3 dimensions, so we set first J equal to 3. This means that we should try sorry, to find between these 3 variables that cannot form a group. What do I mean by this? If I can find 3 variables that cannot form a group, so if I combine them, I cannot form a dimensionless number, then I set J equal to 3. If I cannot find 3 variables between these 5 that cannot form a group, then I say it's not possible to have J equals 3, and then I should try to use J equal to 2. Okay, and I try to search for 2 variables forming independent, forming a group that is not dimensionless. If I find this possible, then I say then J equals to 2 and I proceed. Okay, now I start by 3. Let us check if it's possible to select 3 variables that cannot form a group. What do we mean by this? So in general, what can help me to determine that 3 variables cannot form a group? For example, look, I try to select 3 variables, each one characterized by a dimension that is not present in the other. What do I mean by this? If you take, for example, L, U, and rho, okay? Rho is the only variable containing M. So whatever the combination I do with L and U, I cannot eliminate M. This means that I cannot form a dimensionless group between rho, U, and L. Okay? Now, if you consider, at least between, if rho is included, M cannot be eliminated. I can say maybe I can form a group between L and U, sorry. I can check. Also, I cannot form a group between L and U because I have T that is only present in U. It's not present in L. So I cannot form any group between these 3 variables. Okay? This means that rho, we say then that rho, U, L are independent variables. Independent variables means that I cannot form any group between these 3 variables. Okay? And what is the importance of this? The importance of this is that if I select these 3 variables and I combine them with another variable, then I will be able to form a group. Okay? So the idea is, first I determine N. N is the number of variables. The second idea is to determine J. J is the minimum, if you want, number of variables that cannot form together a group. okay, and sorry, the maximum number of variables that cannot form a group. Here it's 3, okay? And once I determine n and j, I can find how much groups I have. So once I say that n is 5 here, and j is 3, the maximum number of variables that cannot form a group here is 3, okay? So if I combine these 3 with another variable, I should by force have a group. Why? Because I only have 3 dimensions, m, l, and t. So when I combine with a fourth variable, of course, I will be able to form a dimensionless group. So now we say that to calculate the number of groups we can have, we just have to say that the number of dimensionless groups that can be formed is equal to n minus j, which is 5 minus 3 equals to 2. And what will be these groups? The first group will be formed by combining F with LU and ρ, and the second group will be formed by combining mu with LU and ρ. Any question before we continue? Okay.
دكتور
Yes, Hassan.
بس when you were checking for J أخذت ال L وال U وال rho
نعم.
وليش ما طلعنا بالفيسكوسيتي أو بالفورس؟
فينا. أول شيء مش بس مجبورين ناخد، في عدة احتمالات حسن. مش ضروري بس تنقي هول الثلاثة. يعني مثلا كان فيك تنقي كمان فيك تاخد يمكن غير سيستم، مثل مثلا let's say maybe if you select LU and mu كمان بتزبط. okay, it's also possible if you take LU and mu. ليش بتزبط؟ لأنه عندي for example I have M is only present in mu. هلا look in general كيف بنجرب نعملها نحن بنجرب نعملها يعني الفاريبلز اللي بتكون اكيد انت منهم ستريت انه ما في لزوم تقعد تجرب هن اذا مثلا ام موجوده بوحده بس من الفاريبل وتي موجوده بوحده بس من الثري فاريبلز، يعني خلص بتكون اكيد انه they cannot form a group. هلا مثلا ميو مع رو يو مزبوط ما بيعملوا جروب، بس بدك تقعد تجرب منك اكيد، يعني لانه تطلع ال موجوده ام موجوده ساعتها بس بميو، بس تي موجوده باثنين، موجوده بيو بميو. So to be sure انه they do not form a group مفروض تعمل تيست. هلا بقولكم كيف تعملوا التيست. فما تضطر تعمل تيست اوكي you have methods دغري بيفرجوك انه you cannot form a group. يعني اذا بتقدر تنقي 3 variables وحده بس منهم فيها ام ووحده بس منهم فيها تي، ساعتها بتكون اكيد انه ما بيقدروا يعملوا جروب. اوكي هلا اذا بتاخذ ال اذا بناخذ ميو مثلا ورو ويو وال ويو بدنا نجرب نعمل اناليسيس. هلا فينا نقول انه اذا فوتنا ميو معهم ما حيزبطوا لانه ميو بس فيها ام. اوكي كمان اذا باخذ بمجرد ما تكون ميو مع وحده من اثنين او مع اثنيناتهم يعني ما في جروب، فاذا مش الحال. نرجع بنطلع بين ال ويو مثلا، بين ال ويو اليو بس فيها تي، يعني I cannot combine ال مع يو كمان so it's okay. اوكي ساعتها بقول it's fine. يعني مزبوط تي موجوده بمطرحين، بس تي المطرح الثاني الموجوده فيه تي هي ميو اللي اصلا cannot be combined مع ال يو to form a dimensionless group. يعني كمان you can be sure انه ال يو ميو cannot form a group لانه ميو هي الوحيده اللي فيها ام، يعني اذا بحطها مع ال ويو ما بيعملوا جروب مع بعض. شو يعني جروب؟ يعني بلا دايمنشن. انت اذا هون عندك دايمنشن ام وهوليك ما فيهم ام، يعني ام cannot be eliminated، يعني حيضل في دايمنشن بالاخر، يعني they are not forming a group. واذا بترجع بتقول ميو خلص ما فيني احطها معهم، تجرب ال ويو كمان، ال ويو ما فيك تحطهم مع بعض لانه يو فيها تي ما بتروح. اوكي so another possibility بدل ما تاخد ال يو رو فيك تاخد كمان ال يو ميو. it's also right. هلا عادة بنفضل ناخد variables that is انه easier to اذا بدك to change the values. يعني مثلا density يمكن اهين من viscosity. for example انه varying density is easier maybe than varying viscosity. فهول القصص بيأثروا experimental procedure هي بتحدد شو اهين نقي independent variable. So in general بس يكون عندي flow اوكي رو يو ال كثير بيستعملون ك independent variable. اوكي يعني انت بس تشوفهم موجودين وعندك j equals 3 دغري بتنقيهم لانه انت خلص صرت اكيد منهم انه ال يورو cannot form a group so automatically you select that. بس مش غلط تاخد ميو كمان مع ال ويو it will also work. okay it will also work. so
Yes.
نعم
هلا هون نحن عملنا n minus j طلعنا في عنا تو جروب، يعني اذا
مظبوط.
بحال طلع في سيستم تاني مزبوط كمان هداك يعني هذا الجروب بس لسيستم معين، اذا بحال مش سيستم تاني بيكون في عنده كمان عدد معين من
مظبوط
الجروبس.
100%. اذا السيستم الثاني بيعطيك جروبس جداد اوكي بس at the end بالنهايه كفاينل ريزلت يعني اثنيناتهم بيرجعوا بيصبوا بنفس المحل.
يس
اوكي طيب
يس ثانك يو.
well فاذا نحن نقينا هول 3 independent variables we want to form groups now. فاذا قلنا اول جروب can be formed by combining f مع ال مع u مع رو. هلا انتم يمكن هلا دغري تعرفوا الجروب شو هو لانه انا وياكم بعدنا شايفين انه الدايمنشن اوف f هي ذاتها الدايمنشن اوف شو رو تايمز يو سكوير تايمز اريا اللي هي ال سكوير. يعني انتم فيكم دغري تو اذا بدكم تو بريدكت وات ويل بي ذا جروب. بس تنعتبر انتم مش عارفين انه هيك كيف فينا نطلع الجروب هيدا اللي حنشوفه. اوكي so the Buckingham theorem method هي consists on the following procedure to know what are the groups of interest. So once we determine انه الفاريبلز تبعنا independent variables هن ال يورو بنقول بدنا ندخل معهم f بطريقه انه when we combine f مع ال يورو بيطلع لنا جروب. اوكي نحن will combine them بس شو الكويفيشنت of ال يورو ما بنعرف. we set them as unknown. يعني we say we will put L coefficient A, U coefficient to the power B, rho to the power C times F equals to a number without dimension. إذا number without dimension بما إنه نحن عم نشتغل بالام ال تي system يعني لازم يطلع التوتال coefficient لام بالآخر زيرو ولل زيرو وللتي زيرو. This means that it's equal to 1 يعني no dimension. Okay طيب now how I proceed بلش what is the dimension of L. already أنا عامل table dimension of L is L so عندي L to the power A أول شيء. what is the dimension of U. it's LT minus 1 so I put LT minus 1 to the power B. بيرجع شو عندي رو هي ML minus 3 kilogram per meter cube to the power C times F. what is the unit of F. it's MLT minus 2. okay so now all I have to do is to do comparison between these two sides. يعني if I group L terms what will be the total coefficient of L. عندي L to the power هون عندي A هون عندي minus 3 هون عندي sorry بعد في هون B so plus B. From this term I have minus 3C and from the last term I have the coefficient of L is 1 so plus 1 and by comparison this coefficient here of L should be equal to 0. So the first equation I get is by comparing the coefficients of lengths for both sides. بيطلع لي the first equation between the coefficients A, B and C. Now I will move to the second equation. The second equation will be by comparing coefficients of M. عندنا هون from this side M to the power C plus M to the times M to the power 1 يعني C plus 1 equals to 0. This is equation number 2. The third equation is by equating exponents of time. So for time I have T minus B, so minus B and minus 2. So minus b minus 2 equals to 0. This will give me equation number 3. So I end up with 3 equations with 3 unknowns. So I can get the coefficients a, b, c. And as expected, look what I got. What is the coefficient of L? Minus 2. So L minus 2. And b is the coefficient of u minus 2. And the coefficient of rho is minus 1. So rho minus 1 times f equal to a group. So group 1, as expected, is what? Is force over rho u square L square. Okay, this is the first group I got. Now, the second group is formed with viscosity. Okay, so for viscosity, حدا في يقول لي what is the expected group? What will be the expected group with viscosity? With the mu? شو هو الدايمنشنلess number اللي قلنا على طول بيكون موجود للفلو؟ Reynolds number. Okay, what is the definition of Reynolds number? Reynolds number is rho v d over mu. So I expect here, I can expect انه شو يطلع لي الجروب 2. الجروب 2 مفروض يطلع لي mu over rho times u times L. Let us make sure together. Okay, so I say group 2 is L to the power A times U to the power B times rho to the power C اللي هن 3 variables independent variables نقيتهم times mu. هلا ليكم هن هون حطوا mu to the power minus 1 لأنه they predicted to get Reynolds، بس أنتم مش مضطرين، فيكم تخلوه mu، مش ضروري تحطوه، فيكم تحطوا 1، فيكم تحطوا minus 1، فيكم تحطوا اللي بدكم إياه. Okay, so you can select any power you like for your variable، مش ضروري يكون 1. إذا حطيتوها minus 1 بيطلع mu بالdenominator. Okay, so here they wish to place mu بالdenominator، مشان هيك حطوا minus 1. So if they do this, first they expand LA, UB, rho C, etc. فبالنسبة ل L U rho حيضلوا نفس الترمز، يعني A plus B minus 3. But now you have that for mu what is for length the coefficient? It's minus 1 minus 1 and plus 1. So this will give you the equation number 1. For the second relation عنا for mass عنا C وتاني exponent جاية من الميو. It's m to the power minus 1 يعني C minus 1 equals 0. This is equation number 2. Equation 3 is for time. So for time عنا أول شيء minus b, and from viscosity minus 1 is plus 1. So this is equation number 3. And again, I end up with 3 equations, 3 unknowns. But hon system is very simple. Equation 3 will give you b equal 1. Equation 2 will give you c equal 1. And equation 1 will give you, if you replace b and c by 1, you will get the value of a. Okay, so here 1 minus 3 plus 1 is minus 1. Take it to the other side, a is equal to 1. So as expected, your group will be rho u L over mu, which is the Reynolds number. Okay, so what do we deduce then now in this case? We deduce that, okay, we have 2 groups in this problem. So all we have to do, we just have to draw a chart. The first axis will be the group of the first variable f, يعني f over rho u square L square.